Dear friends, this is Mr. Srinivasan, who is having more than 30 years experience in this construction industries, trying to give you a small presentation on how to create a concrete mix design based on IS 10262. Why we required a mix design? The mix designing meant it is a proportion to carry out to achieve the specified characteristic at a certain ages along with the workability of the fresh concreting and durability requirements. This is the image will show you how the batching plants operates. Example calculation. What we are going to discuss about today is how to design concreting grade M, for which the data is required are as follows. Grade designation is M40, type of a cement OPC 43, size of aggregate 20 mm downgraded, minimum cement content 320 kgs per cubic meter, water cement ratio is equal to 0.45, workability exposure condition is severe, method of concreting placing is pumping, admixture type is a super plasticizer. The test data as follows. Cement used is OPC 43, specific gravity of the cement is 3.15, admixture type is super plasticizer as per IS 9103, specific gravity of the coarse aggregate is 2.74, fine aggregates is 2.74. These specific gravity of the materials might change according to the material availability at your place. Simple steps. For doing a design mixes, we have to follow the following steps. We have to design the target strength, selection of the water cement ratio, calculation of the water content, calculation of the cement content, aggregate proportion between coarse aggregate and fine aggregate, mix calculation. Now we are going to talk about a target strength. What is meant by a target strength? For obtaining a certain specific grade of a concreting, you have to design, you have to target in a higher level. For example, if you want a 20 grade concreting, you have to design for a higher grade so that after a lot of a trial and error method, you will be getting a desired 20 grade of the concreting. How we are going to do this, I am going to explain now. Target means thing is equal to FCK is equal to, we always design 1.65 times. Suppose we are talking about a 40 grade, you have to design for 1.65 plus S. S is a standard deviation. That is a 5 Newton per millimeter square, which has been clearly defined in IS 10262. As we are going to design for M40, the FCK will be 40 plus 1.65 into 5 will come down to 48.25 Newton per millimeter square. Now we are going to talk about a selection of the water cement ratio. Water cement ratio has been defined in the table 3 of IS 456. For severe exposure conditions, minimum water cement ratio for grade M30 is 0.45 is a minimum which has been defined in the table. For M40, it is going to be water cement ratio will be 0.40. Now we are going to talk about a calculation of the water content. This also has been defined in the IS code table number 2 of 10262. Maximum water content is 186 kg if you want a slump of 50 mm. Add 3% extra water for extra 25 mm slumps. If you want a more slumps, you have to increase the 3% of the water ratio. 100 mm slumps is equal to add 6% extra, that is 186 plus 6 divided by 100 into 186 is equal to 197 kgs. Super plasticizer used, the water content is reduced by 20% of the above. So now what we are going to talk about, 197 minus 29 into 100 into 197 is equal to 148 kgs of the water. Now we are talking about a calculation of the cement content. Cement content. Water cement ratio is equal to water content divided by the cement content. 0.40 is the water content divided by the cement content. Cement content, water content divided by 40 is equal to 140 divided by 0.40. That is 350 kgs per m cube. As we are planning for a 320 kgs, that is as per IS code, it will be around 350 kgs per m cube. Aggregate proportion between coarse aggregate and fine aggregate. This is again defined in the table number 3 of IS 10262. If plus or minus 5% changes in the water cement ratio, change proportion by plus or minus 1%. From table 3, for 20 mm aggregate, it is required a 0.60, but our water cement ratio has been 0.4. If the water cement ratio has been plus or minus 0.05 changes, in water cement ratio, change proportion will be plus or minus 0.1%. We have 0.1% change in water cement ratio. So add 0.02. That is greater than 0.60 plus 0.02 is equal to 0.62. For pumpable concrete, reduce 10% volume of the coarse aggregate. That is, volume of coarse aggregate is equal to 0.9 into 0.62 is equal to 0.56. Volume of fine aggregate will be 1 minus 0.56 is equal to 0.44. Mix calculation per unit volume. Volume of concreting is 1 cubic meter. Volume of cement is equal to mass divided by specific gravity into 1 by 1000. In our case, it is 3.15 divided by 3.15 into 1 divided by 1000 is equal to 0.111 cubic meter. Volume of water, mass divided by specific gravity into 1 by 1000. In our case, it is 140 by 1 into 1 by 1000 is equal to 140.140 cubic meter. Volume of chemical admixtures, mass divided by specific gravity into 1 by 1000. In our case, it is going to be work out 0.006 cubic meter. Refer the calculation. Volume in all aggregates, A plus B plus C plus D. According to our total calculation, it is going to be work around 0.743 cubic meter. Mass of coarse aggregate is equal to E into volume of Ca into specific gravity into 1000. In our calculation, it is 1140 kg. Mass of fine aggregate, that is volume of all aggregates, which has been mentioned as E, into volume of proportion of FAX into specific gravity into 1000. In this case, it works around 896 kgs. Now, what we are getting is the mass of material per unit volume of M40 concreting. Cement is 350 kgs per m cubic meter. Water is equal to 140 kgs per m cube. Fine aggregate is equal to 896 kg per m cube. Coarse aggregate is equal to 1140 kg per m cube. Chemical admixture, that is 7 kgs per cubic meter. Water cement ratio is equal to 0.040. This all the calculation has been derived from the previous explained starter. Thank you for watching this presentation. In case if you like this presentation, kindly subscribe, like and share. In the next presentation, we will talk about how to do the CF analysis for the material calculation and other details. Thank you once again.